Hi, this is Dan Buddy from Puppet Labs, and today I'm going to be speaking a little bit about our efforts to model OpenStack using Puppet, and also more specifically our efforts to build community around that integration work. So I'm going to start by talking just a little bit at a high level about Puppet Labs, which is the company behind the open source software Puppet. So Puppet, which is our main open source project at Puppet Labs, is something that automates computers. It makes the life of the sysadmin easier by allowing him to automate all the tasks in his life that can be automated. Everything that he finds himself doing repeatedly, he can use the Puppet language to express those things so that he only actually has to do them once. Just to talk about Puppet at a very high level, we have a few words that are often used to describe Puppet, and the first of those is declarative. With Puppet, you declare the actual desired configuration state of systems, and this itself is made up of these basic building blocks that you can specify in terms of what files should exist on a system, how should they be configured, what users should exist on a system, how should they be configured. And each of these, what we call resources, are declarative in that they declare some desired state of the system. They're also idempotent, which is one of the fancy math terms that we throw around here at Puppet Labs to make us feel smart. It basically means that you can continue to run these things over and over again. And idempotency goes hand in hand with being declarative, and that because we're declaring the desired state, we only take action to remediate towards that state if the current state is actually out of sync with that described state. And this is really how Puppet is idempotent, is that we only actually take change if we need to take change. Therefore, if there's no changes to take, it doesn't actually affect the current state of your system. And when we talk about Puppet being model-driven, this is in essence what we refer to as the model, is this ability to describe what is the desired state or the desired configuration state of my system, and then to query some current state to see if it's similar and possibly remediate. And when we talk about Puppet being model-driven, that's really the core of the model, is we have these individual discrete descriptions of desired state and also explicit descriptions of the dependencies between these states that need to be configured. At Puppet Labs, one of the things that we're working on, one of the things that's most important to us, is building reusable infrastructure. And we have the Puppet Forge, which has almost 400 modules to date, where many members of our large community of sysadmins can contribute content so that they can share their common knowledge in terms of automation. And with the Puppet language, we really see one of its prime facilities to be the codification of knowledge. And since Puppet is all about capturing knowledge, the Puppet Forge is the location where our community shares that knowledge. So in this example, you can see, Hadoop implementations from Adobe, where now anyone who is curious about how they implement Hadoop can have a look at Puppet and potentially even use their practices for their own implementations. So I think that we've actually done a pretty good job of building a platform that people can use to codify knowledge so that you can understand how individual organizations, how individuals deploy and install the applications that they use for their business. And so far, Puppet Labs has been pretty successful at this. So now we're going to talk about our new goal, is to talk about how we can build reusable models for even more complicated applications. And I think a worthy goal of something very complicated with a lot of moving parts that is in clear need of standard tools for deployment is OpenStack itself. And for people who don't have very much knowledge about OpenStack, for the purposes of our conversations today, it's really just an application that system administrators would need to deploy into their data center. A little bit more specifically about OpenStack is it's an open source infrastructure as a service solution. You can really think of it as building your own cloud in your own data center and then having APIs that you can use to manage the provisioning of virtual machines into that cloud. And OpenStack is comprised of a few major components. You have the compute service, that's Nova. You have the object storage, Swift. The image service is Glance. Also, the identity manager is Keystone. And one thing worth noting about OpenStack is it's sufficiently complicated. It's complicated enough that there's a book out there about just how to deploy OpenStack. And one thing worth mentioning about this book is it's actually tied to a version of OpenStack that's already out of date. So just to express a little bit more how complicated an OpenStack environment is to deploy, here's is actually a relatively simple diagram, or a diagram that illustrates a relatively simple deployment of OpenStack. You can see here the various services, how they're interconnected, potentially how multiple machines can map to those services. And this is really the level of complexity that we're looking to capture. We're looking to consolidate and capture best practices for how to consistently and reliably provision and then continue to manage your OpenStack infrastructure. And if it's not obvious from that diagram, just to give you a high-level view at all the actual components that really comprise an OpenStack installation, here's an example. It has tons of components, not just for OpenStack itself, and we've created modules for managing Nova and Glance and Swift, Keystone and Horizon. Each of those things is actually composed of middleware. RabbitMQ serves as the message queue for Nova. MySQL can be used as the database for basically all the projects. Memcache is used for caching to speed up a few of the services. Rsync used for Swift. And then even those things are even composed of a lot of base system level configurations. Things like managing syscontrol and SSH and XINetD. So you can very easily see that it is a large collection of things that's used to manage OpenStack. And when we model things in Puppet, the idea is to have as many reusable building blocks or Lego blocks that you can use to compose together your own custom version of the actual application that you wish to deploy. And one other thing here that's worth noting is, although most of these modules actually are from Puppet Labs, you can see that a few, like Memcache, for example, and Concat and SSH, are actually modules that we were able to leverage that had already been created by our community. So going back to the last slide, each of these things that we can see here are modules. And modules in Puppet are used to group together collections of configuration related to a single service. each of these modules is actually composed of n number of classes and defined resource types, which themselves each serve as flexible configuration interfaces that allow you to piece together, that you can piece together to compose these more complicated deployment scenarios. So we're going to go even a little bit further in terms of our goal. It's not just about modeling a complicated application in a way that's reusable by community. It's also about community using their expertise to drive the actual requirements for the project. And one of the interesting things about this project is that we're not actually OpenStack experts. Our expertise is Puppet, is understanding how to codify best practices for deployment, and also how to build community, how to interact with community. So just to quote my boss, Teyo Tyree, using Puppet or Puppetized infrastructure is awesome, but using someone else's Puppetized infrastructure is even more awesome. Puppet's a great tool for codifying best practices, for ensuring consistency, reliability, but actually using Puppet to save you time and using someone else's code is the real goal here. It's all about knowledge consolidation and the codification of knowledge so that it can be reused in a consistent way. So since we're not OpenStack experts, we need to find experts. We need to find people with expertise and use cases that can help drive the creation and maintenance of the work that we're performing. And now I'm going to talk a little bit about the process of building community, about getting engagement from the community, and about some of the lessons that we've learned during this process. I think for anyone that is seriously working on any open source project out there, this is a real fear. You got to fear the fork. And more specifically, you need to respect your contributors and realize that any contribution that they offer, they really need that contribution in the project because they're doing it for their job, because they have a vested interest in the technology. And if you can't merge their code, if you can't work with them in a reasonable way, the fear is that they're going to fork your code. And what we're trying to achieve is consolidation of best practices, the codification of knowledge around systems configuration and automation. And one of the worst things that could happen would be that everyone takes this as a starting place and then forks it off in their own direction, because the community loses their expertise and their contributions, and they lose the future contributions of the community. Or even worse, if everyone forks, there is no community. Everyone just takes the project in their own direction. So the first thing you got to do is you got to be responsive. You have to have tools that you can use to communicate with your community. And the tools need to be easy enough that anyone that wants to contribute, that has an idea, that finds a problem, potentially that wants to offer a patch, which is what we're seeing here, can do that. And this is an example of responsiveness. This is an example of, in this example, me just being a facilitator. You know, someone's nice enough to say, hey, this is great, but it doesn't actually present me the flexibility that I need. And flexibility is definitely one of the main areas where we've gotten contributions, and we expect more contributions in terms of, hey, this is great, it almost works for me. What I need is it to be a little bit more flexible or to work in a little bit more constrained way or a little bit less constrained way. So here you can see an example of someone saying, hey, I need it to work like this. Here's some code. I say, hey, that's great. Call in an expert and say, hey, OpenStack expert, can you verify that this is correct? You know, that actually I've made a mistake in my code, that the patch is valid. The user's nice enough to even say that, you know, here's some documentation pointing to the exact same thing that I'm talking about, and eventually I close it. But I think the main point is be responsive. You know, ask questions, make sure that I understand, that I have access to the information that you know, so I can close that thing as soon as possible. And along these lines, we actually were responsive. I worked very closely with anyone that was interested in using the code, that was interested in contributing to the code, and as a result of that, we merged a ton of pull requests on this large collection of projects. And in fact, just the OpenStack modules have over 300 merge pull requests. And full disclosure, most of those are me. But the great thing is that a percentage of those, maybe 30% now and growing, is not me. This is community and people with real use cases that are just extending my work. And I actually really like this picture that, you know, the community, no more fear of fork, but the fear is how do we not be overwhelmed by all of these changes that the community, all these gifts that the community is now offering us. And just to provide a little bit of information about the kind of things that the community contributes, one is flexibility. Hey, your work is great, but what I really need is one more configuration parameter. I need to be just a tiny bit more flexible. If you could just add this one more parameter or support this one more feature or this one more backend, that would be great. Another kind of example of contributions that we get is just one more operating system. Hey, that's great. That's great that you support Debian. You know, what about Red Hat? Or that's great that all of this works on Ubuntu Precise. What about Debian? And this is a pretty good time to say, all right, we've been successful in that we can codify complicated applications. We can motivate community to contribute to those things so that a larger collection of people can share their experiences with each other. We've been responsive. So now we're getting code. So now the next question is, how do we know that this code isn't going to break someone else's code? How do we know this code isn't going to break everything? How do we know that a contribution that's intended to provide an additional operating system or additional supported operating system doesn't actually break one of the operating systems that's already supported? And the answer is very clearly that we need tests. Just as developers have been testing their applications for years, we need to ensure that we're doing the same thing with infrastructure as code. And I'm going to talk a little bit about some of the methodologies that we use to better facilitate testing. And the first of those is Rspec-Puppet. So Rspec-Puppet is built on Rspec, which is a common Ruby testing library or framework. But before we get into Rspec-Puppet, it probably makes a little bit of sense to talk about the architecture of Puppet first, so that we can better understand strategies for testing Puppet code. So everything in Puppet starts with the computer that needs to be configured. And in this case, we can see the computer has a frowny face because he needs to be configured. He's not in the correct state. So the first thing the computer does is supply information about himself or his facts. The computer says, hey, could you configure me? By the way, here's some information about myself that you might find useful during that configuration process. Here are my interfaces. Here are my disks. Here is the actual processor that I use. Here is the operating system. Here's the version of that operating system that I have installed, and various other information. Those facts then get combined with data that can be set, where that data could be, based on your region, what NTP server should you use? Where should we be doing centralized logging? Those two data sources come in and are combined with the actual Puppet resources that you specify, your declarative configuration that you specify, and this creates a model where the model itself is just a declarative description of the desired configuration state of these systems. It's a description of, hey, you should have a file. It should be configured like this. You should have a user. It should be configured like this. And those things may have some dependencies. Maybe there's a package that needs to be configured before the file's configured. And then finally, that model is applied to your computer, and hopefully during the process, he can switch from a frowny face to a smiley face. Now talking a little bit more about Rspec-Puppet. Rspec-Puppet performs stubbing so that we can emulate facts being specified from the computer. Clearly, it simplifies testing if as opposed to having to run the tests on systems that exhibit n number of characteristics, like being the operating system Red Hat, having the operating system Debian installed. It's way easier if we can just specify those things as code. And this is one of the things that Rspec-Puppet allows us to do. We can let our facts be some hash, where a key value pair in that hash may be that we're emulating having the operating system of Red Hat, or the operating system of Debian, or the operating system of Ubuntu. The next thing that Rspec-Puppet lets you do is also stub the parameters that are passed in. And in this case, we're saying let our params be the hash where we have the key value pair of rabbit host being assigned to the value of 10.0.0.42. So that for the case of Nova nodes, they know how to communicate to the message queue. And the last thing that we're looking at in terms of Rspec-Puppet is Rspec-Puppet is really just a unit testing framework. So the last thing we do is we don't actually send, we generate the model by taking these explicitly specified facts, by taking this other specified data, we generate that model, but we don't actually return that model back to the computer to be applied. Instead, we verify some basic assertions in that model. For example, in this slide, we're saying it should contain a file, and that file should have some content. In this case, verifying that the services would be configured to communicate to the correct message queue. So we're going to go even further with testing, because the things that we've seen so far are actually for unit testing. And the advantages of unit testing is they run very fast. In our case, they're stubbing all the operating system specific information so that you can run them without requiring a large collection of machines to run. And they'll also run very fast because it's not actually configuring the machines. The disadvantage of these things is that we're not actually verifying, is OpenStack installed, does it work? So we're going to talk about OpenStack just a little bit, and the fact that it's definitely not static. It itself is a fast-moving project. And it itself has a community of developers that are contributing code into the common project. And those developers have their own practices. about how that code needs to be tested before it can be accepted, before it can be merged in. And one of the things that OpenStack has is this project called Tempest, which is used to consolidate various integration tests related to OpenStack. And examples of that would be, if I deploy this OpenStack environment, can I create a VM? Can I create a static pool of IP addresses? Can I assign one of those IP addresses to that VM? It actually tests, does the deployment work, and can the deployment do this list of functionalities that's going to be required? With Puppet, what we're doing is we're specifying these deployment scenarios. We're specifying how can we deploy, what kind of multi-node configurations do we support. So when we're testing OpenStack, it makes a lot of sense that we would use Tempest. And in this case, we have a Git repository that stores a bunch of Puppet manifests. And we really need some kind of application that can monitor that code. And when it notices that the code, and in this case, it could be the Puppet code, it could be the OpenStack code, when changes occur, we need to verify that we can deploy an open environment that can itself deploy some specification of an OpenStack environment. And in our integration test environment, it doesn't only deploy the OpenStack environment, it also deploys Tempest as a part of that environment and then runs the Tempest test suite. So periodically, as we receive changes, we have Rspec, which does a lot of verification of, how do potentially changes to one part of the code affect the model that's created, to verify that things aren't stepping on each other's code, to help the programmer catch basic logic errors. These tests actually verify, given these Puppet manifests, that we can deploy a fully functional OpenStack environment, and we verify that using the actual OpenStack project's continuous integration tool, Tempest. So thanks everyone for listening to the presentation here. I just want to leave you with a few links in case people want to learn a little bit more about some of the tools that we've talked about. The first link being the actual OpenStack module that models the configurations and deployment scenarios for OpenStack. I'm actually really excited that should actually be released really soon. The next one of those things is Rspec-Puppet. People are curious and want to learn a little bit more about unit testing of the configuration management code. And the last thing is Tempest, which is the continuous integration or test suite for OpenStack itself.